Good morning, learners and my dear students. This is my fourth video for the third unit of Engineering Thermodynamics, and now we are discussing about steam formation and properties. In the last three videos, you have been imparted about the various fundamental processes involved in the formation of steams and very basic differentiation between the vaporization, evaporation and boiling, how it takes place and how the impact of these processes is affecting the quality of the steam was discussed. And now in this video I'll discuss about PV diagram for pure substances, especially water, how it was different from other substances. Let us move. In the last video itself I told and I have initiated the topic of this PV diagram and its importance. This is the basic coordinate plot which helps us to take all sort of informations and the properties by which you can able to find out or measure how much amount of work can be extracted by the steam from the quality and other sort of properties, right? Okay, so here we are taking a unit mass of ice at the temperature of minus 10 degrees Celsius and 1 atmosphere, which is contained in a cylinder, piston cylinder machine. And you are maintaining the pressures and you are varying the pressures and you are repeating all the experiments again and again at various pressure conditions. Now the ice is being heated continuously at the constant rate, and the variations in volume is observed, and then it is plotted in the PV coordinate, right? So here you can, as I explained in the last slide, here this is the result or the observations or the various data found out at the pressure of 0.5 atmosphere. Now 1 to 2 is melting of that is the initiation of the ice started getting heated. It is from minus 10 degrees Celsius to 0 degrees Celsius. At the point of state of point 2 here, all the ice would be converted to ice, water at 0 degrees Celsius, so that the volume is reduced till it gets minus 4 degrees Celsius, plus 4 degrees Celsius. And again continuously when you are supplying the heat, 3 to 4 is all the water is absorbing the heat, no any phase change occurs. And at state 4 continuously at constant pressure, constant heat, by taking the latent heat of vaporization, all the water is converted into vapor, water vapor, right? 4 to 5 is again the continuous heating is being supplied and the temperature is increased, and 5 to 6 again superheating takes place, right? Okay, so now here this is 0 degrees Celsius, and now next the same reactions and the testing and the processes are repeated at 1 atmosphere and at 2 atmosphere. And here you can able to see here I have shown some large volume change between 4 to 5. What is the reason behind this area or region is nothing but when you know very well that when water is converted into water vapor, water is converted to water vapor at the constant temperature and pressure. You know very well you cannot exactly measure the space occupied by the water vapor, okay? Because when it has converted, after it has been converted into vapor form, it will occupy the space like anything. It would be expanded more, so that volume change only has shown here as a large volume change here. And again 5 to 6 is superheating, okay? So 0.2 is at constant temperature, constant pressure, all the ice is melting and converted to water, and at point 4 or state 4, all the water is converted into water vapor, right? Okay. So again, now here the next stage of that PV diagram is shown here. I can able to view a vapor dome or a continuous curve here, right? This is called that vapor dome, which is nothing but here it is formed by joining all the four. What is the state 4? I told saturated liquid. That is, liquid is saturated. Liquid is saturated. That is all the here. So all the saturated liquid line has joined a lot. 1, 2. Now again, as I told, here the vapor dome, how it has been formed is nothing but here we are joining all the same state points in a single line. All the one lines is being at various pressures is joined together. All the 2 points, all the 3 points, all the state 4 consequent same or coincide states have been joined by lines, so that you are getting this dome. This especially this vapor dome consists of the point or state 4 is joined together at various pressure. That is, this is saturated liquid. Saturated liquid means liquid is saturated with respect to solid phase, right? Here this is and as well as liquid is saturated, and here from here this line you please see 4 to 5, then all the lines of straight horizontal lines of 4 to 5, here at constant pressure, constant temperature, the water, saturated water is converted to saturated vapor, right? So all the 5 lines is 5 here the points meant for saturated vapor line. Here the 4 points or these 4 state 4 in at various pressures meant for saturated liquid lines. Okay, so here one more thing you have to remember, that if you take water is the middle point of ice and water vapor, right? So this water or the liquid phase is equilibrium, or it is in this saturated condition with respect to ice or with respect to vaporization would be seen. Okay, and we have to observe whether that liquid can have 2 saturated point, either it with respect to ice or with respect to vapor. Okay, so here point 1 meant for, again I am repeating, point 1 for minus 10 degrees Celsius, 1 to 2 is minus 10 degrees Celsius to 0 degrees Celsius, or at constant 2 at 0 degrees Celsius all the ice is melted and converted to water, and 2 to 3 again heating takes place, and further heating takes place. 2 to 3 it is converted to water. Okay, 2 to 3 it is converted to water, and 3 to 4 again heating takes place, and that constant temperature and constant pressure 4 to 5, all the water is converted to vapor. Okay, so again those points. So here you can see this is saturated liquid line. This is the left part of dome. Right part of the dome meant for saturated vapor line. Okay, and this is the region. Here you can able to see that dashed line is there. No, the dashed lines are meant for that reduction in volume, which is peculiar only for water whose volume is decreasing on melting. But if you see, this is the PV diagram for other pure substances except water. Here you cannot see that dashed line inside the vapor dome, right? Okay, because there is no any volume reduction here, volume increases on melting, so it is coming, it is going away from the vapor dome. But here it is interacting or intersecting the vapor dome, since because of the volume reduction during the melting of ice to water. Okay, so all the 3 points, all three, the state 3 meant for the ending of the conversion of ice to water. So this is also one saturated lion, liquid lion, and this is also another one saturated liquid lion. This 4 and 3, both lions can be taken as saturated liquid lion. 3 is 3, the state 3, all the lion which joining all the state 3 is called as saturated liquid lion with respect to solidification. Here this saturated liquid lion 4 meant for saturated liquid lion with respect to vaporization. This 2, the line, the state 2 is nothing but ending of that is 0 degree Celsius. 2 to 3 meant for the volume reduction. That's what this 3 is going out here. But if you take here 2 is became the end lion. Okay, 3 has come inside, right? Can you able to differentiate this one? 3 is away than 2, but here 2 is the, for that is 1 to 2, 2 to 3, 3 to 4. Here it is aligned and it is conducted in a sequential order since there is no volume reduction. That is, when they are converted from their solid state to liquid state, there is no any volume reduction in other pure substances as we have in water. So that's what you are having. 2 to 3 is again going in the reverse direction, and then 3 to 4, 4 to 5. Okay, so this is very most important reactions takes place when a constant rate of heat supply is given to the that is what we are calling pure substance, water, from its solid state to liquid state. And another one more thing you have to remember is, at the constant temperature, constant pressure, only the phase change occurs. And that temperature and pressure is also depends upon the another one more saturation temperature or saturation pressure, which is fixed, right? Okay, so if you are conducting the experiment at 1 atmosphere, then at 100 degrees Celsius in the state point between 4 to 5, all the water would be converted to a vapor. Okay, if you conduct the same experiments, if you are fixing the pressure as 2 atmosphere before 100 degrees Celsius itself, because your pressure is high, so before 100 degrees Celsius itself, some around or 95 or 90 degrees Celsius itself, you would have got the phase change from 4 to 5, but the temperature remains constant. So the latent heat of vaporization would be decreasing when you are increasing the pressure. Okay, so when you are conducting the experiments at higher pressure, you will get the reactions in the durations would be reduced, and as well as the properties, everything would be changed. Okay, so here you have to learn that a very important thing is saturation temperature, saturation pressure, and how the reaction is being taken place especially for steam. Okay, and this dome again, if we continue about this dome, means here you can see this is liquid plus vapor region, this is superheated region, and this is the right side of the dome consists of superheated steam region. Here we will not take into account of this left side of the vapor dome, since it is consists of only solid and some liquids are existing here, and mostly we will be concentrating the area inside the vapor dome where the water is converted into vapor, because in the steam power plant and other sort of applications we are taking the water and we are going to heat it, and the conversion of steam is required, means we are going to take the ice, right? So here in the region inside the dome would be considered more for our analysis purpose. Let me continue in the next video. Thanks for patient listening. Meet you in next video. I am signing off, Dr. Suja. Thank you.